Hello. How y'all doing? All right, we can probably get started. There's a good amount of folks here. But yeah, I've been continuing to mess around with some AI stuff. Probably make this a chill, shorter stream today just because I'm not feeling 100%. But yeah, I thought we could check out a few different things. So Kevin, who's on our Discord, and you also probably know, wrote a MCP server for interfacing with the Malware Bazaar API. And I just started checking it out today because I thought that was a pretty cool idea. And basically what it does is it can not only like search the most recently submitted malware samples, but it'll also pull information about those malware samples from the server API and then tell you stuff about it. So, or you can get the AI to tell you stuff about it. So I thought we could take a look at that. And then I also want to expand the Binja MCP server to be able to look at global data. So we can mess around with Binary Ninja and the MCP server that we were developing a couple streams ago. So with that all in mind, we can probably just start with taking a look at the MCP server that interfaces with Malware Bazaar. So here is the link to that MCP server in chat there. I just threw it in. And then if we look at what this code looks like, so basically it has these different MCP tools. If we look at the MCP tools that are available with this MCP server, there's get recent, which will get the 10 most recent samples from Malware Bazaar. There's get info, which you can use to find metadata about a specific malware sample. There's get file, which will actually download the malware from that server. And then you can get malware samples associated with a specific tag, which is pretty cool. Say you're doing like malware research for a specific malware family and it's tagged as such on Malware Bazaar, you could do that. So I already have this set up in Cursor. So again, kind of how the architecture works is you have a MCP agent, which is what I have here. So let me know if that's too tiny, but I just have this chat interface within Cursor. And then again, it's going to use the different, do you work with security? Yeah, I do. That's actually what I'm doing right now is we're doing malware research, but seeing if we can leverage some of the modern AI stuff to help us with that. Basically, this is a LLM agent that I'm going to use to interface with this website called Malware Bazaar. So if I go here, basically this is just a big database that people submit malware samples to, and then they get tagged with various things based on what the malware is, and then what malware families they correspond to, etc. I probably should have explained that to begin with anyways, so hopefully that makes sense. And usually, like if you're doing malware research, you would use an open database like this to see what a specific malware file corresponds to, or what a specific malware family a file corresponds to, and if there's any public information on the piece of malware at that point in time. So, okay, so if we go back here to the MCP server, basically all you have to do to set this up is you can register for free on Malware Bazaar, and then if I log in here, I'm not actually going to log in, but basically if you create an account, you can get a API key, and then once you get an API key, then you can query the API using, I think they have a Python client. So if we look at how some of these tools are implemented, basically it's just using the MCP tool decorator, and then you can do these asynchronous tool operations. And then all that really does is just sends requests to the Malware Bazaar HTTP JSON API and then parses the results and then returns those to the user. So say I wanted to get the most recent malware samples that were submitted to Malware Bazaar. Go back to Cursor here, and then I can just say what the most recent samples submitted to Malware Bazaar. And then basically it's just going to use the tools directly and then list them for me. So nothing super crazy, but pretty cool. And then I can say like what families do these correspond to, if it's known, and then it's going to use the get info tool. And again, I've kind of allowed it to use the tool running mode, which really isn't suggested, or you should basically allow the tool to execute commands as you accept them rather than just allowing them to execute automatically. But since this is within a virtual machine and I kind of understand the MCP tools that I'm using, I'm okay with running them automatically. Okay, so it did the first 5, which is great. So for the first one, there was no malware family identified. For the second one, it just says that there was an HTA file. For the third, it was Mirai. And then there's a few different vendors. I'm going to show you what this looks like on the actual Malware Bazaar website and why it's so powerful. And then for the fourth, it was ransomware rents. I've never really heard of that, but it looks like Integer also marks this as ransomware. And then there is, again, an HTA file without a malware family associated. So if we look at the Malware Bazaar website, what's really cool about this project, again, shout out to abuse.ch for making this project and this publicly available and for free, is you can submit a file to Malware Bazaar, and then you can actually get a whole bunch of different information about that file. So say I click on GULoader sample, you can already see from the tags, well, one, that it's GULoader, and then these intelligence tabs, there's indicators of compromise, there's this ER tab. So if I click on any of these, it'll jump to any of those sections. And then not only will it pull information from the current information that it has within Malware Bazaar, but it'll actually run, I think it'll run it against these services unless it just pulls information from those services. I can't remember. But regardless, we have like any.run. There's an any.run associated with this file. And if I click on that, then I can just go to the any.run website and see the results of that. We can see things like the Cape Sandbox run for the sample. So Cape Sandbox recently came back online because it was now funded again, which is awesome. So if I go to the Cape Sandbox results, then we have, this sandbox is freely available and open source. So definitely check it out if you haven't heard of it before. But basically this will show dynamic analysis results of running this within a Cape Sandbox instance, which is valuable. And then we have other services that are available like hybrid analysis and Joe Sandbox, which is the one that identified it as GULoader. And then a whole bunch of different services, Hatching Triage, which also identified it as GULoader, etc. I'm not sure why Unpacked is spinning here, but, and then we have things like YAR signatures, file information. So the fact that this was dropped by a malspam campaign, so a malicious spam campaign, and then a delivery method was specified, again, the Cape Sandbox run, and then associated APIs. So like a whole lot of really good information if you're actually doing malware analysis that's automatic and available to you, which is really cool. So that's why these kind of MCP interface tools can be so powerful, is that they can not only pull information from this database, but also give us a summary information about those samples. So what I kind of wanted to look at today is if we could not only pull information from the Malware Bazaar database, but if we could use a multi-agent approach of not only querying Malware Bazaar for information about the malware, but also seeing if we can gain insights into the code itself by also using the Binary Ninja MCP server. So I have no idea if it'll work. Maybe it won't work at all. But so the next thing that we can do is I have kind of a use case here. So we have a malware study group on our Discord, but basically we have a malware study group that we look at a different piece of malware for a fixed amount of time. Currently, we're looking at the Stealer, and this is, again, kind of more malware analysis automation that I leverage, where I threw this in here, and this sample actually corresponds to a Malware Bazaar run here. So I'm going to open this link, and that's from Assembly Line. I forgot to mention that, but again, another open source project that you should check out for malware analysis and reverse engineering. But so this is a current sample that we were looking at for our malware analysis study group called KoiStealer. So if you all want to check out the Discord, you can join there. But okay, so the reason why I was looking at this particular sample is because it was submitted by somebody called Humpty Dumpty, who's on our Discord server, for us to look at because it's not too difficult to analyze. And again, I submitted this to my local assembly line instance, and then it said that there was indicators of compromise associated with it. So I go back here. If I go back here, we can see this, that ThreatFox had identified. So ThreatFox is another project from abuse.ch, also another really cool project that they store indicators of compromise. And then there's a Malware Bazaar entry again for this sample. So I thought we could use this as kind of a test bed for our MCP server, pull the sample, open it with Binary Ninja, and then see what else we can figure out about the sample automatically. So does that sound okay? Do you guys think that sounds cool? I know a lot of you just like seeing straight malware analysis, but I think a lot of this automation stuff is also really important because you're really not going to have time to manually analyze every single malware sample. Let's get vi reversing, yeah. Okay, so let's ask about this specific sample. So I'm just going to restart a new chat instance. And I'm just going to say, can you, the sample, connection failed. Let's try that again. Okay, cool. So it was able to get a whole bunch of different information for us automatically using the Malware Bazaar MCP server. And okay, so let's just take a look at what it found. So you can see that there's a file called cityapril.lnk. Okay, so this actually might not work because it's an LNK file. But let's take a look at what it says here. So malware family KoiLoader, download an LNK. Okay, there's PowerShell within the LNK file itself. There's suspicious LNK commands. We could probably take a look at what this looks like on Malware Bazaar. I thought this was the actual KoiLoader sample, but it looks like it's just the associated LNK. But if we look at this, maybe we can see if, like on hatching, anything was actually downloaded, because then we can just get the malware sample itself. So looking at so Triage is pretty nice because it's able to not only extract obfuscated PowerShell from the LNK file, but it's also able to deobfuscate it, which is pretty awesome. And here in this instance, this LNK, which is a link file on Windows, I should probably specify that, is essentially querying this URI or URL on this likely compromised domain, and then it's setting an environment variable. I'm not sure what that's particularly used for. And then it's downloading a PowerShell script from that URL. Okay. And then if we look down here, we could see that it's written in C++. So I wonder if it actually got a C++ file. There's a C#. Are all these different stages or what? Let's see. Maybe it's just hitting specific SIGs that are showing that. Okay, yeah, here we go. So, okay, so this is like a huge infection chain, it looks like. So there's a curl that's made, and then there's a schedule task that's created for this JavaScript file in program data. And then there's W script that's executed to execute another JavaScript. And then there's, let's see what else, PowerShell. I don't see okay, so this is probably the executable. So I wonder if that was observed. Let's see here. Okay, let's see. Program data. I wish it would tell me the file type. There's a whole bunch of memory dumps. Okay, maybe we'll try a different example rather than this pre-baked one that I wanted to use, because I don't know if response 200 okay. Okay, so definitely downloaded it. Maybe we can kind of pivot here real quick. If I can download I don't really want to log into my Triage account on here. Okay, let's check out what else we have on Malware Bazaar, and then we can go from there. But yeah, we were able to query that. Maybe we can just take a look at another KoiStealer tag. So say we want to find more samples, I can say something like with the KoiStealer tag. Okay, yeah, we got a bunch more. So are any of these portable executables? Still getting information. So like, again, if we wanted to figure out which of these was portable executable, in theory, we would have had to write a script to query the API, pull the file type, and then like look for portable executable in the return results, right? But just by using this MCP server, I don't have to write any code. I can literally just ask the LLM to pull all the info associated with all these files and then see which one is portable executable, right? So it's pretty cool. I don't know how accurate this is, so let's see. So this one's an actual exe, and then we'll go on Malware Bazaar and search for this with the tag. Okay, yeah, it's a type exe, so that was correct. Okay, I kind of want to try the download functionality, but let's check out the, was this sandbox activity associated with this hash. It's just going to link the reports. Okay, cool. Yeah, we should have some stuff here. So it's not actually telling me. It's like, you can visit these links. If you want specific information, can you tell me? Okay, so let's see what it says. So behavior signatures based on Cape and Triage. There's loads, possibly drops executable additional payloads, which is good to know. Enumerate system information, including the language, possible hardware. Hey, Rico CZ, what's going on? Just tuning in. Have you tried 03 or 04 Minio for RE? I haven't got to it yet, personally. It's funny you should say that, because I was actually messing around with 04 Mini this morning using this interface for cursor, and it seemed to be pretty good at analyzing code directly. We can mess around with that directly if you want for the Binary Ninja portion of this stream, if you'd like, Rico. Because yeah, it seems like a way more affordable option than some of the others. I'm currently using it's like the $20 a month plan for cursor. So I can, if I go to this auto thing and then deselect auto select, then I can see all these different servers that are enabled, and then I can just pick 04 mini if we want, but for now I'm just going to keep auto selected, so we can keep using things that are going to be selected automatically by cursor. But okay, so we can see a whole bunch of different information that was returned, and we get a C2 address. I forgot to mention that earlier. The fact that it's a PE, reversing labs, had a bunch of detections. VxCube, UnpackMe detected it as KoiLoader, so that's pretty cool, with a UEC bypass and other suspicious behaviors. So that's pretty awesome. I don't know how much I want to do this download thing because it freaks me out, but let's see how it's implemented, because then it'll maybe freak me out less. Okay, so get file. Okay, I think it just downloads the zip, so that's not a big deal. Okay, so client post, headers, response equals 200. He checks the first 16 bytes for PK, which means it's a zip, so that's cool. Gets the current working directory, so it should be able to write to this directory, I think. And then creates a temp file and then saves it there. Yeah, it looks okay. Oh, cool, nice. These are reasoning models. Actually, you need a large context window instead of reasoning. Do you know which models are not reasoning? Define AFK, or do you have any suggestions? Because there's like, are all of these reasoning models? Like Claude Sonnet is also reasoning. I didn't think it was, but in Gemini Pro. Gemini 2.5 has 1 mil. Yeah, for the context window, yeah, for sure. Yeah, we could just set that and try it. We can, I don't know, set a bunch of these and try different context windows for the malware analysis. For this stuff, I think it's pretty straightforward, just because it's literally like querying the JSON API and then interpreting the results. But okay, so let's download this. Let's see if it works. I'm just going to specify the hash again. You download sample. Nice. Password infected. All right, so let's see if that actually worked. 7A. Oh, it did not download to that directory. Let's see. It should be in the MCP server directly based on, or directly based on the code, I think. I don't know where it downloaded to, but it's definitely not in the downloads directory unless I'm missing it. Oh no, it's there. Okay, cool. Yeah, so that was accurate. So let's put this in a separate folder. So like eventually I could write, I don't really like the MCP server executing commands directly because there's a bunch of different poisoning attacks for the prompts and stuff, but like in theory I could be like, and open it in Binary Ninja, and then this MCP server could open it in Binary Ninja for me without me doing all these manual steps that I'm doing right now. Let's say we do like MCP testing, 3, okay. And then let's unzip this. I think I need 7-zip on here. Okay, I have it. All right. And then I'm just gonna defang this. And by defang this, I mean make it not.exe. And then let's open it in Binja. And I don't know what the sample is gonna look like because I have not looked at it before. So we'll see how, I don't know if this is packed or not, but we'll just see what we can find out. It doesn't look packed, but I could be wrong. This could just be like CPU ID. Okay, yeah. So I'll leave that for the MCP server because this looks like an anti-analysis trick. Unless this is just, this actually might just be compiler stuff. I think this might be, yeah, it's SRT initialization. Okay, sorry, ignore what I just said. Okay, let's see. But if all those YAR hits fired, then it should be, actually, do you know what we can do is check on UnpackMe if, was this sample packed to UnpackMe? Was the sample packed according to UnpackMe? Look at that. Where's Sergey? I want to show him this. If you deselect thinking in the model selection, you can see which ones are not reasoning. Oh, cool. Okay. Keep in mind, unless you're using Gemini, keep in mind, unless you're using Gemini Max, in cursor, the context is cut to 100K. Oh, cool. Nice. Thanks, Rico. I was actually, I could really use you. I don't know if you were on that stream when we were talking about, it looked like that. I think I'm using Claude Sonnet, but do auto select. And then maybe let's UnpackMe, expose the malware before it exposes you. Yeah, totally. So, okay, so I don't know if this is available. Is the sample in Malware Bazaar? Oh, it's not. We could unpack it if you guys want. I wonder if there's a way to like automatically determine if it's packed. Like there's all this stuff that looks like it's encoded data. Let's see. This is a bunch of standard C++ stuff. So, all right, why don't we just have it analyze this pack sample to see what it can find. It's gonna use a lot of tokens, but that's okay. Let's see if we can just get it to analyze this particular function. And then maybe, yeah, it's dynamically resolving functions. Yeah, let me not manually analyze this too much because I really want to see what it can find. But where is this? Yeah, the P, nice. Binja's gotten pretty good at handling these offsets automatically pretty well. So built-in DCB and timeouts A, current process. I wonder what these are. Anyways, let's get it to analyze it. because, okay, it should be able to find it. So, hey, what's going on here? First time here. Hey, Janu Wagaba. We're just looking at analyzing some malware using these like AI services that I wrote one of them, and then our friend Kevin wrote one as well. So basically, just to give you some perspective on this, we're using this free service called Bazaar to do malware research. And then I'm using these AI interfaces called MCP servers to automatically query the API using these large language models and this like agent interface in order to query information about them, or about the malware samples. Hopefully that makes sense. And then I just downloaded the sample and I opened this in this tool called Binary Ninja, which you can use to disassemble and then analyze code, any type of code, but we're using it in this instance to analyze malware code. Okay, so let me reinitialize this MCP server instance for this particular sample. Okay, so let's see if we can hybridize our approach here. So we will not only, I'm going to create a new chat and we'll see what information we can pull about the sample on Bazaar, and then ask it to also analyze it with Binary Ninja, which I have open here. So all I did in the background there, it wasn't this API key that I was worried about, is my Bazaar one, but basically I just generated a new API key in order for my Binary Ninja MCP server to work with Cursor. And then now we can ask questions about the Binary Ninja database, or at least in theory I should be able to. So I'm just going to renew this instance, and then I'm going to set the context up again so that we're talking about the same sample on Bazaar. So let's do a new chat. Then I'm just going to say, what do you know about the sample on Bazaar? Okay, so a whole bunch of context. Good. This is my first time seeing the MCP stuff. Nice. That's cool. Thanks for joining. Okay, so we have, again, that sample context in which it should know that, there's like, this malware is called KoiStealer, and then the delivery method was that, and that the file type is portable executable. And I could say, what information know about this based on the file being open in Binary Ninja. So now I'm going to see if it'll actually make use of the Binary Ninja tools in addition to Bazaar. Okay, so that worked. Then I could say, so yeah, this information confirms that it is a typical portable executable with a substantial code section and a large resource section, which is common for malware that may pack or embed additional payloads. That's so cool. The number of functions and symbol suggest a non-trivial program, possibly obfuscated or packing. Man, this is crazy. Okay, so let's say starting at the start function, can you try and find where there is deobfuscation code? Make sure you rename functions as you go and ensure that you look at functions that are called by other functions accordingly. Okay, so let's see. So it's going to get all the function names, and then it's getting the disassembly. Okay, I'll check what it's doing in a sec. So it got all the function names, and then it queried the start function for the disassembly of that function. It's looking at 4049A, which is here. And then you can see it like doing stuff here. So decode string it found. Let's see. Okay, so now let's see what it found. Here's what it found so far. Following the execution of the start rename functions for clarity. Start is CRT startup. Yeah, so that's like the C runtime startup stuff. Run initializers. Main entry immediately calls 403690. Performs stack setup. Yeah, blah, blah, blah. With what appears to be obfuscated strings. This is a strong indicator that deobfuscation routines and decoding routines as it is common for malware to store strings. The function sub403D10 is called with these obfuscated strings, and it returns the value that it stores, suggesting likely obfuscation or decoding function. I'll examine 403D10 to confirm if it is a deobfuscation routine. So then it looked at that function. It changed it to decode string. Okay, and then let's see what else it did. Okay, starting at, okay, blah, blah, decode string. Each time with what appears to be obfuscated string arguments, this pattern, calling functions, blah, blah. As I follow the call graph, as I continue following the call graph, I will continue renaming them. Okay, let's take a look at this decode string function. At this point in time, there's not a ton that Bazaar gave us in terms of support for the malware analysis itself, but it's still a cool hybridized approach where you can say like, hey, did Unpack me determine that this was packed, or did these other services determine like other things? So I think it just renamed this. This function is called repeatedly with obfuscated strings from the main logic, likely responsible for deobfuscating or decoding strings at runtime. Okay, so let's get it to continue analyzing these, because yeah, it looks like this is quite complicated. String too long, so this is like an error case. Okay, let's see if we can figure this stuff out rather than me doing it. Continue analyzing the functions called by decode string. And then after, we can probably take a look at the smaller models to see how they fare against, I don't know which ones are being used right now, but I like how I was doing it all based on the disassembly, not the pseudocode. It's pretty interesting. Okay, so it's going to read all this. Can you rename these functions based on your findings? So let it do that. I just want to see if we can find the decoding stuff. I don't know how complex the decoding routines are, but okay, so renamed a bunch of stuff. Main copy wrapper, optimize memcopy, calculate buffer size, deobfuscate the buffer, or deobfuscate to buffer. Let's look at that. Memcopy wrapper. So we look at the disassembly, which is what it was using. Validate string line, max value, min value, character traits, end of file. Stack cookie stuff. I'm just gonna read. I guess I shouldn't rename stuff because we need the MCP server to do it. Okay, I must have figured that out based on the standard C++ APIs. Okay, memcopy wrapper, optimized memcopy. Let's look at the decompilation. Yeah, this looks oh, built-in memcopy. Maybe that's why it named it that. This looks a little bit more complicated than an optimized memcopy. Okay, this might be a decoding routine. But what was the decode, deobfuscate to buffer? Calculate buffer size, increment, allocate, memcopy wrapper. Where's it actually doing the deobfuscation? I don't know if this is correct, to be honest. Okay, okay, let's go back. But that, yeah, that definitely looks like the decode string routine. And this is going to be the obfuscated buffer. So I definitely think it's in here. I just think that optimized memcopy wrapper might be the actual decoding routine. I'm going to ask it why it thinks that this is the optimized memcopy. Okay. The function uses registers and stack arguments in a way that matches the pattern of copy in memory. Okay. See, like once it has the context that this is malware, it kind of changes a lot because it, that's okay. I'm just going to ask it, like, this is kind of a Hail Mary, but can you, it's not a simple XOR or arithmetic deobfuscator. So it's giving up. Can you try to identify the helper functions to re-implement it? I should tell it to use the pseudocode because it's definitely just doing the disassembly for everything. Yeah, this is just kind of nonsense now. It's kind of disappointing. But, so the obfuscation may be trivial, just copying or handled elsewhere. Let's see if I can get it to, figure this out, because this definitely doesn't look memcopy. I'm probably just going to try and unpack this myself next, and then we'll move on to see what it's doing. Did it actually use the, oh, it did, SIMD, and then let's look at these are function hashes probably, yeah. I want to see if you can identify that stuff too. Okay, let's do this function. All right, yeah, it's still preferring to use disassembly, which is interesting. No, use the, okay. Currently doing CTF trying to get into summer school, and they select 20 people based off their performance. Nice. Have to hand it in on the 1st of May. How's the CTF going? What kind of, is it like offensive stuff? Cool cat work. It depends. Okay, so it's like everything. It's like a normal CTF. Okay, so I'd like to write a, so yeah, this looks like pretty standard stuff. So if we go back to the code now, then it'll be quite a bit more readable. So resolve API by hash, hash API name. So it identified all that stuff correctly. And then it uses get module name. This is the module itself and whatever these function pointers are called. So yeah, it's probably reflectively loading the unpack stage after the deobfuscation routine. I mean, yeah, this is definitely doing the deobfuscation steps. Let's see. I wish we could get it to figure out the decoding routine. Hey, you stream often. Every Tuesday, JPI. We're on the Tuesday schedule right now, around this time on Tuesdays. Cool. Okay, so the MCP server couldn't figure out the deobfuscation logic. To be fair, it is quite complex, but if we want to resolve this, we would have to do this dynamically, which I can do right now, if you guys are interested in that. And then we can look at the Unpacked payload. That's pretty chill. I'll try to be here more often then. Yeah, sounds good. Thanks for joining. Okay, so yeah, I should have got my Unpack Me account set up, but let's just do this dynamically because it's more fun. So I have my Win10 box here. It needs to adjust the, okay, let me copy over that sample though. This is the sample, and then we're going to unzip it. It's already .exe, and then I'm just gonna use, I can't remember, was it 64-bit? I don't think so. It is not. I know Knox was working on a X32 debug MCP server, so maybe we could try that next time. First time here, never tried vibe reversing before. Seems interesting. What models are you using? So I'm actually using Cursor, and then I just have like the auto selector mode enabled. Are the tools dissimilar dependent? No, these are just the regular models that are available. Tumpus. Okay, so let me open this sample. I'll just unpack it real quick, and then we'll go from there. But it's probably extracting it from the resource. But I need to get the correct address. So let's do show in memory map. And I'm just going to copy this address over to our Binja instance, rebase it. So you go to it in Binja, you go to analysis and then rebase. And then I'm just going to set that base address. And then let's take a look at this decoding routine to see if I was right that it was actually that subfunction that I called optimized memcopy. So let's just break on this entry point here, and then I should really just start using the Binja debugger stuff because it's pretty cool. But let's have that run, and then let's see what these string decodings look like. So we have this obfuscated string that's pushed onto the stack, and then we have the deobfuscate to buffer call, and then the debug mallocator, calculate buffer, increment decrement helper. Oh, this might be it actually. No, allocate memcopy. It's probably just like a really basic deobfuscator function, but I think it's handling the alphabet. Okay, so let's go here, deobfuscate to buffer in our debug instance. Let's see which function is going to deobfuscate this. It might be in a struct, so it might not be like completely obvious. Okay, so it looks like it was this one, maybe, if that is the deobfuscated string. But let's just look at this address. Okay, that's the calculate buffer size. Yeah, that's definitely a decoded string. So, oh no, that might be the key. I'm just kind of rushing through this, so I can see if there's anything super obvious. But since we probably want to unpack this, then it might not even be a string deobfuscation routine. Yeah, it's definitely not obvious to me what portion this is. Okay, so as always, we don't want to spend too much time on the unpacking routines because it can be quite complex. I started listening behind the binary, and I got excited for malware. Nice. I was talking to Josh last week, I think, so the host of that podcast. When I see all this, I feel so lost. I feel like I'm missing programming knowledge or something. What would you say are important fundamentals? Yeah, definitely programming for sure. I'm kind of doing stuff quickly and not. Basically, I'm just like looking at these deobfuscation routines real quick. I'm not going through them line by line just because they are C++ and they would take quite a while to go through. So I'm just looking for like really basic patterns. But yeah, overall, definitely suggest getting some background in programming, whether that's like C or C++ would be great. And then, so yeah, these actually might not be decoding routines. This might just be setting up the string classes because they're not actually being deobfuscated. But this might be actual key data here. And then this is probably the decoding for the character sets. Sorry, I keep getting distracted by the binary. But anyways, yeah, so C, C++, any programming background that you can have is definitely great. If you can understand operating systems internals, like how processes work, how network connections work, how threads work, how, basic operating system fundamentals to the point where you can see a function call or something on Microsoft Windows, a low-level API call, and be like, okay, this is what that function is used for after being able to read the documentation, etc. And then what's definitely important is once you understand a higher level programming language is then being able to understand an assembly language. It doesn't have to be x86 assembly, which is what this is, Intel x86 assembly, especially since ARM is being used more and more now. But if you can get a low level understanding of how the disassembled code works in these reverse engineering programs, then that'll help you a lot. Because I know I'm using the decompiler a lot, but it's really not optimal for a lot of things just because it messes up a lot of the time because it's like an approximation of what the original code was. So you're basically lifting it up a bunch of levels, and Binary Ninja, you can see that. So like you go from the disassembly to this low level intermediate language, and they keep lifting it into these higher level representations until you get to this like decompiler view, which is what I'm using. Anyways, that's all to say that yeah, that's kind of what I would suggest in terms of a path is programming language, lower level programming language, assembly, operating system fundamentals, and then reverse engineering. I know that sounds like a lot, but that's kind of the path I would take. And you could start on really basic malware too. There's really nothing that's forcing you to look at complex stuff like this when you start off. There's a lot of good examples. I'll plug our training because, that's why I do these streams, and I can offer these streams for free. So I run this training, Invoke RE, and this is, let's see. Yeah, what Sudhi said is also very true. Write your own C programs, open them up in like a decompiler, disassembler, and then see if you can analyze them. So yeah, there's our training website there. I'm just messing around with this AI stuff, but if you actually want to understand what's going on, I highly suggest learning reverse engineering properly rather than doing vibe reversing, which is what we're doing today. Because as you can see, even like just that first function that I analyzed, this is just setting up the string functions. It's not decoding it in any way, shape, or form. So definitely threw us off and threw us for a loop. So if I go back here, but yeah, not to say you have to, and we have a whole bunch of free resources. So if you go to our website, like on YouTube, there's all the past streams that we have. And then we also have a GitHub as well. So a whole bunch of free resources. You don't have to like actually grab the training if you don't want. Our GitHub here has a whole bunch of stuff. Yeah, I've been looking at a bunch of different vendors, yours included. It's just a bit daunting to drop so much money. Yeah, for sure. If you're a student too, we have student discounts. So, or a recent grad, we also have discounts for them too. Okay, so let's go back to our debugging, which was here. When you were first starting your career, was your repo kind of disorganized? Yeah, definitely. If you look at the Invoke repo, it is kind of disorganized to begin with, but I'm kind of joking. But yeah, definitely don't need to code perfectly or keep everything super organized. Okay, so let's look at some of these routines. So these are all internal string stuff, but I think these are the decoding routines that we want. So let's step to this in the debugger, and then let's look at these for loops, because I think this is probably the decoding routine that we want. Back again, this window setup isn't optimal, but Okay, I'll get rid of this string setup breakpoint. Okay, yeah, so it looks like those were just C++ functions to construct this big long string. Again, the vibe reversing kind of threw us off, not great. And then this is probably going to be a decoding routine. And let's see where this is writing to. This is actually, I think, just getting the length and then subtracting by 1 for ECX. So let's go to this jump less than. I don't really want to click through these because it's going to take forever and be boring. So let's set a breakpoint there. And then let's see where this is writing to. Into this stack buffer. Okay, so it looks like it's just doing that temporarily. I think this is still just getting the length. Okay, so there's a bunch of jumps, and then we're probably gonna have the decoded buffer down here. And this is probably not even gonna be recognizable in memory. Okay, we have our ECX here. This looks like a pointer to that string. And then, sorry, I know I'm doing this all quickly, but it's just because it's not super important how most of these C functions work. So I'm just trying to see if there's actual meat and potatoes here. So our return value is this. Again, might not even be recognizable as it could just be a key that they're decoding. Yeah. So I do know in that LNK that we saw, they were decoding a environment variable. So we might actually not even have the password for this, but let's see if this actually does unpack. So let's go to here. It said on unpack me, they unpacked it. So I don't think they actually need that password. So let's go down here past all these decoding routines to that function where they were dynamically resolving that stuff that the vibe coding found, or vibe reversing found. Resolve API by hash here. So let's go to this function, and then let's have it resolve these APIs to see what APIs are being called. Okay, so let's see what this first function hash is. Again, we could use better methods for this, but find resource. Okay, so it's just gonna extract the resource, like the AI told us, which is kind of funny. Okay, so it's loading the resource. Now that it's done that, it's probably gonna load the resource and then deobfuscate it. Down here, allocate, optimize memcopy. So maybe that was a memcopy earlier that I thought was the decoding routine. Okay, so this is gonna be the resource. And then it looks like it's going to, this is probably the original entry point here. So this one, this is calculating the address of entry point, I think. So let's have it do that. But I did kind of want to see yeah, this is mapping the portable executable. So let me see what you guys are talking about. I've been a SOC analyst for the last couple of years, and I seem to be stuck in the false positive hell. Yeah. How do you approach determining whether DNS is being abused? In Zeek plus F Grafana dashboard, I have DNS logs that show DNS queries. Yeah, it's definitely hard to determine whether malicious or not. You kind of need threat feeds for that. little off-topic question, either to Josh or anybody in chat. A few weeks ago, I started my first programming job. So far, all the tasks take me about twice as long as my coworkers. Is this generally okay for the first 2 months? Yeah, like it's definitely okay to be slow at first, for sure. Once you get used to the code base and stuff, I think it gets better. I see www.stage in the text DNS field. I think there's a lot of weird DNS queries that come across networks. Like Chrome will do these weird queries to check for connectivity, and they look like domain generation algorithms, but they're not. Yeah, but yeah, definitely slower at first. When I started like my main malware analysis job, I was like 30 times slower than all my coworkers, but I got better over time. So, okay, so let's jump to this address, which is probably the address of entry point. So this is a really good demonstration as to why you shouldn't just trust AI, because it kind of led us on a wild goose chase. Okay, so this should be the address of entry point of the, I was just double checking that my share was read only, which is good. Okay, this should be in the Unpacked sample. So if we follow this and dump here, this is our Unpacked sample, but it's currently mapped in memory. I kind of want to see if we can get it before it's unmapped. So if we look at the die resources here, so I want to see if we can get it before it is mapped is what I meant to say. Okay, so if we look at the executable here in die, it has this resources part here, which lets us look at the resources. And then we have these RC data segments, which this is probably a key. And then this is probably the encoded data, which is the portable executable. So those are the parts that we kind of skipped over there. So if we go back to the find resource A calls or the load resource calls, we can probably get it before it's unmapped. Or sorry, before it's mapped. I keep saying the same thing. Okay, let me get rid of some of these breakpoints though. Okay, so load resource is called, and then I believe this should just be the encoded data, which should map what we have on disk. Yeah, see how it's DE here and then DE here. So the load resource API basically loaded it into memory. And now what I can do is see where this pointer is accessed. So this EAX is going to be moved here. And we can even cheat a little bit. I kind of see it as cheating, but setting a breakpoint, a hardware breakpoint on that byte, and then see where it's accessed. And then it's being moved in this routine here. So move SB. So then if we look at the destination register, then I can see it's being moved into that address. And if we continue walking in this debugger, I can see each of those bytes being mapped or being written to this buffer. So now what I want to do is set a breakpoint on when this buffer is accessed. Let's say that byte. And then we have, is this load resource being called again? Okay, so it's loading the second resource. Okay, so I don't know why that hardware breakpoint didn't hit again, but anyways, let's just dump the mapped one because it's a little bit easier. So if I go to this follow in memory map here, then this is the mapped one, but we can use Scylla to access that address. And then we can go to the entry point here. So this is our address of entry point. So I'll use Scylla to see if we can do an IAT auto search from our current address. Usually the advanced one is better, it really depends, but so here we can see a whole bunch of APIs that are resolved in this mapped address. And then if I use get imports, the IAT is not inside the PE, it requires rebasing. Okay, so that might cause us issues, but let's dump this. We want to dump the mapped memory, not the, let's check the chat here. Yeah, I'm going to keep looking. Devs do the most freaky things in their programs. Like WWTF is www.stage. Yeah, I'm not sure. Glad I know I'll not be replaced just yet. Yeah, definitely. Okay, so we can go to dump memory in Scylla. And then this is where it's in memory. So if I go to follow in memory map, then we can see it's at this C address. And then if we go back to Scylla here, C quadruple 0. And then if I dump this as a PE, then we'll do that. Let's just say o.bin and then o.mem. And then we'll do fixed dump on this o.bin. And then, so we just applied that import address table. And then if we want to like clean this stuff up a little bit, we could just do, okay, so it was the correct file size. So then let's see if I open this in, we can use Binja. What was the starting goal for this rev? I kind of just wanted to mess around with the AI tools, to be honest, but this kind of, we kind of went off track here a little bit. Okay, so dump looks pretty clean and we have functions. So that's how you unmap something dynamically using Scylla and then dump it to disk. So that looks like a really clean dump. So let's use that now that it's unpacked. We probably could have found the unmapped one, but that's okay. now you guys have a decent idea of how to do that. I'm just going to copy it over into a folder that doesn't have anything else in it. And then we'll have the MCP server see what it can find about this, or what it can find out about this sample in Binja. Okay, I'll put that there. I haven't used anything related to MCP. Honestly, just heard about it. Could you talk about it for a bit? Yeah, for sure. So I'll go to the blog I did on this over here. So how this architecture looks is, so I have this blog on the Invoke RE website that talks about this particular plugin I'm using, not the Malware Bazaar one, but basically how the architecture looks is there's a MCP or agent client. So in this instance, we're just using Cursor here, and Cursor basically it's basically an application that knows how to call these MCP APIs. And this application can be told to call a specific MCP API based on the response from a large language model request. So what makes this fairly interesting is this is how the architecture looks overall, where we have this Cursor agent calling the MCP server, which calls an API into Binary Ninja over this HTTP API that I created. So what makes that unique is that the LLM can choose to call any tool it wants. So if I say like, hey, can you analyze this function? Then it can decide to call the function disassembly function, which uses an HTTP request from Binja in order to acquire the disassembly for a given function. So the reason that's interesting is because us as humans, in order to create automation on the fly, we basically have to make like these sequential steps where, hey, I want to analyze this function disassembly, and if it has this, then we'll make this decision or whatever. But having AI do it makes it a lot more flexible in that we can just say like, hey, is this function doing this? And then we don't actually have to tell it to call those APIs. It'll just do it automatically based on its decisions. So it's pretty interesting. I don't know if you were here earlier, ND Pointy, but it kind of led us astray with some more complex functions, but it's pretty good at analyzing some more basic functions and kind of giving us an overall view of the binary. So, and it was able to determine that it was likely packed, which is pretty cool. Now that we unpack this, let's open that up. But before let me get it open just so we don't have to wait on the analysis. Not that it'll take very long, I don't think, but I do have to run to the washroom. So I'm going to go do that in just a sec here after I get this unpacked version open. Okay, so now that that's loaded, so yeah, I'm just gonna run to the washroom real quick. Again, kind of what makes all of this possible and lets me do streams for you all for free is our training. So I'm just gonna throw a link of that in the chat, and then I'm just gonna throw a quick ad up for that while I run to the washroom, and then I'll be right back, and we'll get the MCP server to analyze this unpacked malware sample. So it'll be 2 seconds here.
Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you.
All right, sorry about that. Man, this computer pumps out hot air. Like it is so hot in here. And it's like pretty warm outside, so even with my window open, it's still like smoking hot. Everybody doing all right? You have any questions? Is that an AI generated song? Yeah, it is. I use Suno, if you've heard of this thing. It's pretty cool. I'm also a musician in my part-time, so don't want to take those jobs away either, but it's like, I don't know, it's like okay, but it is pretty cool, and you can just throw up like stuff like the song I made for the waiting or be right back and intro and stuff. Okay, so let's check out this. So I'm gonna have to reinitialize my MCP server here. Okay, and then we'll open the chat again. So let's do this MCP analysis. So if we go back to our chat here. Okay, so okay, so should we try those smaller models that we were talking about earlier? Or do you guys want to just try the automatic agent stuff? So we can do, I'll just show you guys what I'm talking about. So if we go to model, I can select auto select, which is what I think I had before. And then if we don't want to select a thinking model, I don't believe. So we'd want like 3.5 Sonnet, or is 04 mini thinking? Oh, it is too. So we probably don't want that. So if I deselect thinking, it's just gonna select Claude 3.7 Sonnet by default. Anyways, maybe we'll just set it, since nobody's really saying anything, I'll just use auto for now. Okay, so let's get it to, you are an expert reverse engineer. Begin analysis. You need to analyze this binary with binary ninja starting at the start function and mark up all functions as you analyze them based on the control flow with their respective function names, with their respective function names, add comments, and change variable names. Remember to use both the function disassembly and pseudocode when analyzing them. How's that prompt sound? Okay, let's see how this does. Nice, I got some cross references. It's doing a lot. First thing I think about is infinite loop prompt 10 out of 10 would vibe. Nice. Yeah, I think there's definitely potential for an infinite loop. I think Cursor kind of restricts that from happening with their system prompts on their end. Because I feel like it could just like go for forever. But yeah, I think that was a pretty good prompt. See it like, it's like you hit 25 tool calls and then I have to hit resume conversation. So at least it has those. Okay, so we have a lot of output. Okay, so actually what I should have done is, okay, let's just take a look at this first, and then I'll get us to use a namespace so we know exactly what it changed. But check VM sandbox, let's look at this function that it changed. Okay, start, checks the system language, then runs complex command loop, if not target language, calls all of those functions, contains large command parser and execution logic, okay? So if we go to the function that it analyzed, this does indeed look like anti-VM stuff. So it's looking for Hyper-V based on the enumerated display devices, VMware, Parallels, Display Adapter, Red Hat QXL controller. I don't think I've seen that before. That's interesting. And this is just, wow, 64 redirection stuff. And then it's looking for VirtualBox. Oh, cool. And then it's looking for these documents. So maybe these are sandbox documents, recently.docx, recently opened. Are these files? Are these hard-coded in some sandbox? Resource openvpn.txt. I don't know what. New songs. These look like all things that are in a default sandbox that I'm not aware of. Jennifer Lopez and Pitbull. That's cool. Super random. Jax. Wallet.data. Okay, that's looking for Harry Johnson. There's a lot of really good anti-sandbox stuff in here. Damn, there's so much in this function. Bait. So it looks like it adds bait if it finds that it's a VM. Okay, so that's cool. Set up mutex and environment. Oh, Red Hat XQL controllers QEMU. Cool, that's good to know. Which model is Cursor using under the hood? I think it chooses based on the task, JPy. Cryptacquire context. Okay, so I'm just gonna say creates a mutex based on the volume serial, initializes critical sections, sets up networking and cryptography, the environment and privilege escalation, expands the environment variable system directories. Okay, so let's look at the setup environment and escalate function. Okay, I kind of took a look at this beforehand, so I think it probably missed this just because it can't access global variables yet, which I kind of wanted to add. I don't know if we'll do that today because we're kind of running low on time, but this elevate administrative COM object stuff is to bypass UAC. So that is indeed a privilege escalation. So that's interesting that it identified that. Crypto, random, and key setup. Let's look at that. Hey, Precision DNB, how's it going? We should listen to some DNB. Okay, so I'm just going to, I'm just going to get it to continue because those are pretty accurate assessments. But before I do that, I'm going to say change the function names that you renamed to have the vibe namespace. This just makes it easier to track. I attempted to update the function name. Oh, weird. Why did it think it had that function? It's likely Stealer malware. Uh-oh, it might have went off the rails. Would MCP stuff also work in Windsurf? Yep, I think so. I think Windsurf has MCP support. Let's see. But yeah, it would definitely work in VS Code because they have MCP support for Windsurf. Yeah, it does. It looks like Cascade MCP integration. Yeah, it looks like it. So yeah, this would all work in there too. It also works in, what's that free? It's like basically like a free cursor alternative. I always get their tweets. For some reason I can't remember off the top of my head. Okay, didn't rename these functions. I don't know why they do that. Okay, is that all of them? Duncan and Sergey use it. Okay, is that all the ones? Okay, cool. Okay, let's get it to, I'm just gonna say what languages are checked for in the start. Like this is really good cripping code base. No, that's not what I want you to do. Use the start function to indicate, oh well, it would help if I could spell, but I could probably figure that out. Trey, TikTok. No, it's not that one. I started using the code companion with Gemini model and UVim. Oh, cool. Nice. Okay, cool. Yeah. So it resolved these. So these are all the languages that it's checking for. Then I'll just say like, can you add that? So like this is stuff you don't really want to do yourself, right? Like having to look up all those languages and let's look up the IDA MCP server. I think he'll probably mention it. Let's see here. Klein. That's what I was thinking of. This one. Klein looks pretty cool. I know there's like a million VS Code forks that do this. So, but this is like completely open source and I don't know how they make money. I don't know if they do. Careers. They have like people there. So definitely. Okay. So let's get it to, okay, let's see what comment it added. Okay, cool. Yeah. So it has all these now. Okay. So do we want it to continue analyzing any of these? Expands the environment variables, check the system directories, creates and sets up a JS file, checks the user info, attempts to column elevation. Yeah, cool. Nice. Can you, okay, I'm going to get to analyze these subfunctions because I'm not sure what they do. Oh, they have people there. So they have coffee and a couch. Some resemblance of food. Yeah. Chances are they got start funding. Yeah, totally. They have 500K worth of credits. That's wild. I should get on that with my startup. Can you comments with function name changes and comments, please? I don't like that. I have to specify that every time, but it kind of makes sense. They have a pay tier and they buy tokens in bulk. Oh, that's cool. That makes sense. What's up, orcs? Bitwise key scheduling algorithm. If I recall, one of these was using, I did not mean to close that. Let's see. Yeah, this is all like crypto stuff. Not entirely sure what crypto API this is, but we could probably use Cape to, or not Cape, Kappa to figure out what this is potentially. Doesn't look like there's a ton of constants, so some crazy optimized crypto stuff. Okay, so let's just have it continue. I think there's definitely like context window limits here. The functions that are called by the start function and mark them up with comments, including their sub functions called based on the call graphs. Can you also change their function names, add comments, and change variable names where applicable, please! Exclamation mark. RE always seemed like too much pain until MCP. Now it looks kind of interesting. Well, if you were here earlier, you would have seen that the MCP server messed up and led us on a wild goose chase, but that's good. I am a strong believer that you need to have real reverse engineering experience. And it's like vibe programming, right? Like you can only do so much with these tools before you don't understand errors and code structure and stuff like that. So yeah, like anything else, exactly. All right, it's doing a whole bunch of stuff. I'm getting connection errors from, and now it's all hard to read. Okay, let's see what it changed. I know it's hard to read, but it's because it went to the error state. Set up mutex. Oh, there we go. Crypto random and key setup. Collect system identity. Launch PowerShell payload. HTTP post user agent. Okay, let's check this out. Let's see, where's the, okay, yeah. So it's using the WinINet API is pretty standard. And then this is called in a whole bunch of places. So interesting. So like, I just want to point out like nuances, like what crypto is it using? What encoding algorithms is it using for the C2 stuff? Orbital gun. Oh, thanks for the raid. Chad B Noob. How you doing? Hackers Unite. Yeah. Our new friend is locked in. Yeah, sorry. How's it going? How's everybody doing? Thanks so much for the raid. Really appreciate it. Everybody go check out Chad B Noob. What were you guys working on today? Chad B Noob. Unless you got to go, then don't worry about it. I'll throw this in the chat. Everybody go and follow Chad B Noob. Okay, so just to give everybody, all the raiders a background on what's going on. So I use this program called Binary Ninja to help me reverse engineer binary programs. So if I split this and go to the disassembly, it'll basically take disassembled instructions in a given binary, disassemble them into these assembly instructions for me to understand, and then it also lifts them into this like pseudocode representation. So if I go to sudo C, this is like a pseudocode representation as to what those assembly operations are doing. So you've probably seen a lot of other programs doing this, like IDA Pro or Ghidra, which is free, et cetera, et cetera. But what I'm doing right now is messing around with AI in addition to Binary Ninja in order to help me with my reverse engineering process. And it's using this project that I wrote. If you go to Invoke RE on GitHub, it's just this MCP server. So I'm going to link that here. Yeah, and it's a strip binary. And this happens to be malware code that we're analyzing with this MCP server. So yeah, and I'm basically just having the AI mark up different functions based on their contents, and then we're kind of going and verifying the contents of those functions that is marking up in order to see if it's right or not. Okay, so if I look at this launch PowerShell payload, it looks like it's looking at a .NET framework environment variable that it's expanding. So it's probably looking for a specific .NET framework version because the PowerShell payload it's dropping is probably doing something that it needs. So then there's this command and control address there. And then once it downloads using open on this PowerShell command that it's executing this. So if I make this a char pointer or wchar pointer, parsing details or parsing failed. Let's see, how big is this guy? Copy as, so we want to divide it by 60 bytes. Maybe it's wchar underscore t. Okay, so now if you go back, it'll show more of that C2 address there. Yeah, I wish Binja handled the wchar characters correctly on its own, but I don't know why. I would have to basically like go through and mark up all these characters or all these global variables. It gets the gist of it, so that's okay. So if we go back here, I don't know what this is. He shared it earlier. Study. Yeah, that's the sample. Open in VM. Yeah, definitely don't execute that on your machine if you're running Windows, obviously. I should preface that. Okay, so let's see what else can we see if we can identify. Get to count, extract next command. So it looks like it does a post request, and then if the response is init, then it does the sequence of executions to count. Okay, I could probably see if it can analyze what this is. So what's good about the AI stuff is it's pretty good at, or should we just get it to continue with these? Okay, let me do this first. Okay, cool. So yeah, so this is a random number generator called Mersenne Twister. I actually knew that beforehand because I reversed some of this stuff already, but so that's correct. So that's like what some of these MCP servers are really good for, is that it can analyze something like this. So if I go to into Binja, then we can see like these constants, these constant values. It can recognize those as particular algorithms. So like that's really cool. I don't know why it's starting to analyze these. That's random. Well, it's late for me. Gonna head out. Yeah, sounds good. Take care, JPy. Thanks for joining. Appreciate it. I'm probably gonna wrap things up pretty soon here. Usually do 3 hours. Okay, let's continue analyzing the main functions here. I just wanted to show you that it's good at marking up those particular functions. So see these calls to the PRNG. These are going to be like value ranges between these lengths. Then it changes it to an integer and then assigns it to this variable, then subtracts. I don't know why it's subtracting. Okay, so it's getting, is it randomizing the command that it's getting? If that's the case, that's kind of weird. Okay, I'm just going to get it to continue analyzing from the start function. No, don't see. It's like, I think we're hitting the context windows now. Can you continue analyzing the functions that are not marked as vibe from the start function and mark them up accordingly with function name changes and comments. Make sure to analyze the functions that they call based on the control flow. I wish I could have uploaded this to Bazaar to, but it would have kind of told us the same stuff that we saw earlier, so it's not really a huge deal. Network connection handler, proxy relay function, 2 TCP sockets. It does look like what it's doing, and that's creating a separate thread, so that's super interesting. On localhost, it looks like. So is this, let's see, this guy's still going. What other functions are not analyzed in start here? These are all heap free. I'm just gonna get it to keep doing the same thing. Here, I'm just gonna kick this off, and then I'm just gonna run to the washroom one more time. So let me do this. Okay, so I kicked that off, and I'll be right back one more time. I'm just gonna play that ad again before I go, and then we'll see what this MCP server says about the remaining functions. Be back.
Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you.
All right, sorry about that. Okay, so process hauling and injection, native process injection, clean up and exit, clean up Firefox traces. I don't know what that is. Let's look at it. Okay, let's look at this injection one. Okay, process hauling implementation that injects into malicious code into legitimate Windows processes. Okay, let's check this out. Okay, unmap view section. Yeah, it definitely looks like process injection. Cert util, create process, reprocess memory. Yep, write process memory. Yeah, it reads the relocation table. Nice. And then it looks like it has the option of injecting into Explorer based on this EAX value, which is probably an argument. Yeah, so this is a struct. Oh no, this is based on this offset. Anyways, we could probably reverse this for real on a different stream in order to understand this function entirely, but that's pretty cool. Okay, and then we got native process injection. So let's see how that differs. Advanced process injection techniques using native APIs for stealth. NT-create process. Yeah, nice. So it uses our random Racine twister. Nice, that looks correct too. The MCP server seems to be doing a lot better with this particular sample. I think simply because it's so straightforward. Okay, so we have cleanup and exit. So it looks like it gets that JavaScript file that it created during initialization. So this is actually cleaning up so this isn't actually Firefox components. So it actually creates a task that it uses with this name, Mozilla and Firefox browser agent. So this is actually cleaning up the scheduled task that's used for persistence. So that's not correct either, but this is why it's like so easy for the LLMs to get confused, because it's like fixating on this Mozilla and then Firefox default browser agent, but still got kind of the exit stuff and cleanup correct using this 6A case. What were the other functions? I think that was it. Yeah. So is there anything else that this hasn't gone through yet? This is heap free, heap alloc, handle plugin. Plugin module management function handles dynamic loading and execution of malware modules. This is pretty cool. I wonder how it came to that conclusion though. I'm just trying to see here. I don't know how it came to that conclusion. Again, we can probably reverse this properly. Maybe next stream. Let's see. Global stuff, release. So maybe what we can do next stream, because I know I've been doing like mainly Binja stuff for a while, is look at this sample in IDA and see if we can reverse it ourselves. But it looks like that's the majority of the functionality. It didn't get the shutdown function for some reason. Let me see if I can make this a little bit complicated for it. I'll say like, what does the case 69 command do? Again, hitting those connection limits. Okay, let's take a look at the database here. Acquire shutdown privileges. That is indeed what it's doing. And then initiate shutdown. So yeah, case 69 here for the commands that are received is going to be just initiate shutdown command. Okay, so let's see what else. Acquire privileges, initiate shutdown. I think that's kind of it from what I can see from the start function. So it basically has the ability to drop and execute additional malware, drop a PowerShell payload that it does by default if it's not within a virtual machine. What are these? I don't know what this is. Crypto stuff. This looks pretty complex. Yeah, I think this is crypto stuff. Okay, so yeah, we could probably take a closer look at this next stream to figure out the crypto stuff that it's doing, exactly what crypto operations is doing, and then actually reverse this properly. But the automation gave us like a pretty good overview as to what the binary does, how it handles certain commands, etc., etc. So still probably saved some time using it. again, kind of as what always happens, like we had to get past that packing stage, which was quite complicated because it was using C++, but the actual functions it was using, it was just the resource, loading the resource from the portable executable. Oh yeah, I didn't do this one. Let me get this guy. The vibe namespace as its function name, analyze any subfunctions that it calls, also add comments and change variable names based on what it does. I can never really get it to change variable names, but yeah, saved quite a bit of time. The Bazaar stuff is pretty cool. So shout out to Kevin for doing that stuff. Let me link that in the chat. So there's that project. And then again, here's the Binja project. So, okay, so for those of you who, so yeah, this is gonna finish this stuff, which we can check out in a second. So again, kind of what makes it possible for me to do all this stuff is we run this training stuff here. I won't go through the whole spiel, but that's what gives me time to do all these free resources and streams and open source projects and stuff. So if you're interested in malware analysis, please check that out. Again, we stream every Tuesday. After these streams, we upload everything to our GitHub, all of our notes that are just here. So I'll just shoot that over, or I guess you have a link to it, but here's the parent link. And then if you want access to our Binary Ninja databases and whatever, then we have a premium tier thing that you can use to access those. So definitely check this stuff out. Let's see if we can raid someone after I look at these functions. Let's see what I renamed here. So generate random key. But I hope you thought this was interesting. Basically just trying to find ways to speed up some of the reverse engineering process, but definitely not trying to, okay, so yeah, I did find the MD5 hash implementation, so that's cool. From learning malware analysis, as we saw at the beginning of the stream, it kind of went completely off the rails and misinterpreted a bunch of the stuff. And it usually takes me kind of intervening and making sure that it's not doing anything crazy in order for it to not just burn a bunch of tokens. But at the same time, it can definitely do things like recognize MD5 and do interesting things, which, you know, we don't really want to spend too much time doing ourselves. So yeah, so that's kind of why I'm still looking at the AI stuff, because I want to see if we can make it better and then add functionality as we go. Thanks, Buddy, for hanging out. Really appreciate it. Yeah, really appreciate everybody hanging out. I hope you have a great week, and we'll see you next week. And if you didn't catch this whole stream, it'll be up on our YouTube. So just search Invoke RE on YouTube, and you'll find all of our past recordings there. So let's do /raid. Oh, and before I go, I know some of you might have difficult jobs, so just remember,
never give up.
Never give up.
Never surrender.
Never surrender.
Never give up. 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 Never surrender.
Oh, shut up.
No. Never give up. Never surrender. Never give up. Never surrender. Damn the resonance cannons in full speed ahead, huh?
so never give up, never surrender. Even if you're reverse engineering a sample that's super hard, even if you're looking at a million security events, whatever, just keep going. It'll get better, I promise. Okay, so I'll do that raid. And thanks everybody for hanging out. Really appreciate it. Have a great week.